Okay, so Bill is preparing to make an ice sculpture. He has a block of ice that's 3 feet wide, 4 feet high, and 5 feet long. He wants to reduce the size of the block by removing the same amount from each of the 3 dimensions. He wants to reduce the volume to 24 cubic feet. You need to write the polynomial function to model this, and how much should he remove. So although some of these things, because you hope and you pray that it's going to be a nice thing to factor at the end, you can't just guess and check to get full marks. These are worth usually about 4 marks on an exam. So, and I'll show you all the marks that you're getting things for. So the first thing is, let's draw a picture of what this is all about. I don't know, so let's draw a block of ice. I'm not the best artiste here, so does that look good? And it's 3 feet by 4 feet by 5 feet, yeah? And he wants to reduce the size by removing the same amount. So that's going to be our unknown. We don't know how much he's going to remove. So we're going to say let x equal the amount to be removed in feet. Okay, so the first thing is you need to come up with, well, before we come up with the restrictions, let's think about this. If we're going to remove the same amount from each of the dimensions, does anybody know what the new dimensions would be? If x is the amount I'm going to remove. Yeah, so I'm going to maybe change color here. It's going to become 4 minus x, 3 minus x, and 5 minus x. Does everybody see that? So now that we know how much we're removing, what are the restrictions of x? Yeah, so at first we're saying it can't equal 3, 4, and 5, which is true, but it has to be even more restrictive than that. So I heard it can't be less than 5, and then I heard it can't be less than 3, or sorry, it has to be less than 3, and that would be true. So x has to be less than 3. Can it be negative? Can x go all the way to negative infinity? No, because dimensions have to be between, you know, it has to be more than 0, right? Because if you start subtracting something that's bigger than 3 here, you'll see you have a negative dimension, which doesn't make sense. Okay, so now we have to come up with the volume polynomial. Does everybody see the volume polynomial would be length times width times height, or length times width times height there. So 3 minus x, 5 minus x, and 4 minus x. So that's your first mark there, is coming up with the volume polynomial. And so the next mark is coming up with the equation to solve. So do I set it equal to 0 to solve? What do I do? You set it to 24. They're giving you this information because they want the volume to be 24. So here's your next mark. 24 equals 3 minus x, 5 minus x. A lot of people think you always set it equal to 0, but if you were actually going to set it equal to 0, do you see you'd get a 3, 5, and 4, and you didn't change anything, right? So how are we going to solve this? Yeah, we need to multiply this out. So let's multiply this first. So that's a FOIL. So what do we get when we get a FOIL? We get 15. Outer we get minus 3x. Inner we get minus 5x. So that is minus 8x plus x squared. And then I still have to multiply it by 4 minus x. When I multiply this now, does everybody see it's a distributive property? So I have to multiply 4 times 15, 4 times minus 8, 4 times x squared, yes? So 24 equals 4 times 15 is 60. 4 times minus 8 is minus 32x plus 4x squared. And then we have to multiply negative x times 15 is negative 15x. Negative x times negative 8 is plus 8x squared. And then negative x times x squared would be negative x cubed. So again, I always say don't try to factor things when you have a negative coefficient for your leading coefficient. So I'm going to move everything over to the right side here, so I get sorry, the left side, x cubed, and then I can combine 4x squared and 8x squared is 12x squared. So if I move it over to the other side, I have minus 12x squared. Then I have a minus 32x and a minus 15x. Yeah, so minus 40. So if I put it over to the other side, it's going to be plus 47x. And then if I move the 60 over to the other side, and there's a 24 already there, what would I have? Minus 36 equals 0. Okay, so now I'm going to do the remainder theorem to see if I can come up with something. Okay, does everybody remember my restriction says it has to be between 0 and 3? So what should I choose? Let's try 1. Okay, so try x equals 1. So 1 cubed would be 1 minus 12 plus 47 minus 36. So I have 48 minus 48. So we get 0. So 1 worked. Okay, so now we're going to go synthetic division with 1. So that's 1, negative 12, 47 minus 36. 1 multiply 1, negative 11 multiply. What is that? 36 multiply, and we get no remainder. So then, now some people think, oh, I found 1, I'm done, that's my answer. You have to show that there's no other solutions possible, because technically you could get some solutions from here. So what does this represent here? Okay, so can we factor this? No. And what is the best way to check if you can factor other than guessing and checking? No. Part of the quadratic formula, what is that? B squared minus 4AC. If it's a perfect square, it's factorable. If it's negative, there's, yeah, imaginary. So there's no solutions then. Okay, so if this happens to be negative, then we're done. So B squared would be negative 11, the whole thing squared would be 121 minus 4 times 1 times 36. 36 times 4, 24, 144. So 121 minus 144 is definitely less than 0. I don't even need to go any further. That means there's therefore no other solutions possible. And you have to state that. They're looking for that in the answer, that you've exhausted everything. So the only possible solution for Bill to do is to remove 1 foot from each dimension. And like I said, you probably could have guessed that it was going to be 1, but they're looking for all of this to get the 4 or 5 marks. So therefore, Bill should remove 1 foot from each dimension. All right. We're good? Okay, let's move on to the next one. 3 consecutive integers have a product of negative 210. Write a polynomial function to model the situation. What are the 3 integers?
These are the questions that you always get in the
Oh, the math contest, yeah. Okay, so we don't know what the first, does everybody know what a consecutive integer is? Yeah, like numbers in a row. Yeah. Okay, so if let x be the first integer, what would the second integer be then? Not y. X plus 1. And the next one would be x plus 2. Yes? Does everybody see? Those are 3 integers in a row. You could have also had x minus 1 and x minus 2. Yes? Okay, so now the product. So we need to come up with a product. So if I multiply those 3 integers together, I will get x times x plus 1 times x plus 2. So there's my first point, right? So now I'm going to sub that in, the information in. So negative 210 in for p of x for my product. Now, Does everybody understand when you multiply 2 times 3 times 4, I can multiply 3 times 4 first, then the 2, and I get the same answer? Yeah. So what I recommend is foiling this first, and then just multiply the extra x in after, because it's a lot easier, because we're pretty good at foiling. So x times x is x squared times x is x cubed. So outer we get 2x, inner we get 1x, so we get 3x, right? Times x is 3x squared. And then last I get 2 times the additional x is 2x. Everybody good with what I did there? Just a fast way of multiplying. So I'm going to move the 210 over. Now, was there any restrictions on my x? Yeah, so it has to be an element of integers. So let's say where x has to be an element of the integers, right? You can't have decimals and all that stuff. Somebody brought up the fact that it can't be 0. And I thought, yeah, that's a good restriction. Why can't it be 0? Yeah, because if you multiply by 0, you get 0 as your product, so that's not going to happen. Mind you, you know, you would have figured that out later, but anyways, so really we have to start with factors of 210 here. So where do you want to start? Okay, so just remember, if this is 1, if x is 1, this would be 2, and this would be 3, and if I multiply that, I'd never get anywhere close to negative 210. So first off, it has to be negative. Second off, it has to be way bigger than 1. So what do you want to try? Well, but negative 10?
I would say negative 21.
Negative 10. Well, negative 10 will go into that. So let's try negative 10. Okay, so then we get, what is negative 10 cubed? We're at a big number now, hey? Negative 1,000. I think that this was a little bit too big, but anyways. Negative 10 squared is 100. 100 times 3 is plus 300. Minus 20 plus 210. So that doesn't work. No, I think we need to go down a number. Let's go down a number.
Negative 5.
Negative 5? Okay. Huh? No, we have to find that it equals 0. So negative 5 cubed would be negative 125. 5 squared is 25, so plus 75. Minus 10 plus 210. Do we get it? No. Go bigger.
Negative 7.
Negative 7. Let's try negative 7. What's 7 cubed? Huh? 343? Well, let's just try. 49 times 7, yeah, 63. 343. Very good. Okay, so negative 343. So then we have 7 squared, which is 49 times 3. So that's what, 132? What's wrong? Oh my gosh, what am I doing here? 9 times 3 is 27, 147, yes. So plus 147, and then 2 times minus 7 would be minus 14 plus 210. Yeah, it looks like it works. So because it's a non-calculator, and traditionally they're putting this on the non-calculator part, they'll just make sure that the number's a little lower in number to deal with. But yeah, you get 0, so it works. So negative 7, and then we get 1, 3, 2, 210. So 1, negative 7, negative 4, what, 28, 30, negative 210, so then we get a 0. So this represents x squared minus 4x plus 30. Does that factor? 1 and 30, 2 and 15, 3, and 10. Well, let's do b squared minus 4ac and see if there's any more. So that would be 16 minus 4 times 1 times 30. In inspection, you can see that it's going to be less than 0. Therefore, no more possible solutions. Again, you have to state that. You have to investigate if there's more. Sometimes I throw in that there is more. So if x is negative 7, what's... Therefore, the integers are what? Try again. Negative 6 and negative 5. And just test that. Does that give you negative 210? Yeah, because we're adding each time.
And it's divisible by 6.
Okay, we good? Yes? Okay, a boardwalk that is x feet wide is built around a rectangular pond. The pond is 30 feet and 40 feet long. This time it's surface area. So I'll give you a picture. We have a pond that's a rectangle, and then we have a boardwalk going around. That's x width. That's all we know, except that the total surface area of the pond and the boardwalk together is 2,000. Oh, sorry, we do know that the pond is 30 feet. What am I talking about? So it's 30 feet from here to here, and this is 40 feet from here to here. So if they're giving you that the total combined surface area of the pond and the boardwalk is 2,000, does everybody see they're giving you this whole entire big rectangle, yes? So if I can figure out what that dimension is, we should be able to go. So what is that dimension there? Huh? Well, if it's 30 from here to here, and this is an additional x, and this is an additional x, so what would this whole length be? 30 plus 2 x's, right? And if the 40 is here, and this is an x, and this is an x, this would be 40 plus 2x. So the area, A of x, is equal to 30 plus 2x times 40 plus 2x for my first point. Any restrictions on my x? Yes, x has to be greater than 0. Yeah. Even if it doesn't say.
Okay, well, how do you know that it's supposed to be?
Does it have to be less than everything?
Because we're not subtracting, it's not apparent, but I know at some point it'll be bigger than 2,000, right? So, but we don't know. Okay. Well, we know that we can't have negative dimensions, so that's why x can't be negative, right? This doesn't give us any additional information, so we're just going to go with that right now. A lot of the times if you're subtracting something, if you subtract something that's bigger, then you'll get negative numbers, so you know you get a restriction that way. Okay, so second point is subbing in the 2,000 equals. So let's FOIL this. 30 times 40 at 12 with 2 zeros, yes? Outer I get 60x, inner I get 80x. So how many x's do I have? 140x. And then last I get 4x squared. So I'm going to move the 2,000 over, and I get 4x squared plus 140x. And then if I move the 2,000 over, I get minus 800, sorry. Now, Algebra 101 says if there's something I can divide both sides by, do it. So what can we divide by? Yeah, that'll make it way easier to factor. So I get x squared. If I divide that by 4, I get what? 35x. If I divide that by 4, I get minus 200. Yep. It's funny, some people didn't realize they could do that. It's like dividing both sides by 2, right? Or adding 2 to both sides. Whatever you do to one side, you do the other. You can do that. That's a legit move in algebra, right? So what is this factored to be? 5 and 40, very good. So x minus 5, x plus 40. Yeah? Which means x has to be 5 and minus 40. And guess what? Because of our restriction, we can reject that. I don't have to look for any more solutions because those are the only two solutions I have. Okay, so if x has to be 5, that's our answer, I guess, because it's asking us what is the width of the boardwalk. Therefore, the width of boardwalk is 5 feet. All right. The width of a rectangular prism. Let's draw a rectangular prism again. Do you remember doing this in like junior high? Or, no? Something like that? Okay, it says the width of a rectangular prism is W. So I'm going to make the width W. The height is 2 centimeters less than the width. So what's the height going to be? W minus 2. The length is 4 centimeters more than the width. So what's the length going to be? W plus 4. If the magnitude of the volume of the prism is 8 times the measure of the length, what are the dimensions? So first mark is, how do I find volume? Length times width times height. So W times W plus 4 times W minus 2. Remember that trick I told you before? Multiply that first, then the W, yes? So W times W is W squared, and another W is W cubed. Outer I get minus 2W, inner I get plus 4W. So that's plus 2W with an additional W, that would be plus 2W squared. Last gives you minus 8 with an additional W would be minus 8W. So now what is that equal to? My volume is 8 times the measure of the length. This is my length right there. Yes, 8W plus 32. Very good. Okay, let's move it all over. 0 equals W cubed plus 2W squared. And if I move the 8W over, I get minus 16W. If I move the 32 over, I get minus 32. Is there a restriction in my W? Has to be greater than 2. Very good. Any questions on why it has to be greater than 2? My height would not be legit. That's right. Well, look at the dimensions. If you have a width that's, say, 1, could that be possible? 1 minus 2? Dimensions have to be positive, right? So, like this W right here, it would have to be greater than 0, but this is more restrictive, right? So, anyways, so we can't choose 1 or 2. So what should we choose? 3? Does everybody see why restrictions help? I'm not going to just randomly pick numbers 1 because it's not 4? 3 doesn't work. Why not? Because it has to be a factor of 32. Very good. Somebody was paying attention. Okay, so we're going to try 4. Oh, sorry, not x equals 4. W equals 4. Does anyone remember what that theorem's called that says that 3 wouldn't work? Integral 0 theorem? Okay. 4 cubed, 64. 4 squared, 16 times 2 is 32. 4 times 16 minus 64 minus 32. Look at that, it works. Right on. Okay, so now we're going to divide that 4. So we get 1, 2, negative 16, negative 32. Bring her down, multiply. Bring her down, multiply. Bring her down, multiply. We get 0. So that represents x squared plus 6x plus 8. Does that factor? It does. Oops, I went a little too high. x plus 2 times x plus 4. It is w. What the heck am I doing? Okay, I'll try. That would be introducing a variable. So let's try again. W squared plus 6w plus 8. So that factors to be w plus 4, w plus 2. So, therefore, w can equal 4, negative 4, and negative 2. But what are we going to do? We're going to reject these two solutions. So again, we show all the possible solutions and then we reject it. So now we got to go back and answer the question. What are the dimensions of the prism? So if w has to be 4, the dimensions are 4, what is this? Is this feet? Centimeters. 4 centimeters by, what does this have to be? 8 centimeters by 2 centimeters. Because it has to be greater than 2 in here. It's the same thing over and over again, so we'll just do a couple more for practice. Honestly, there will be 1 question on the test for a word problem. So, but that's why I do lots of examples, because at least then you're practiced up. Okay, so a monument consists of 2 cubical blocks of limestone. The smaller block rests on the larger. The total height of the monument is 5 meters and the area of the exposed surface is 61 meters squared. Determine the dimensions of the blocks. This one I'm going to actually use my pictures to. Okay, so this is the picture of what it looks like, and it says the total height is 5 meters. So that means from here to here is 5 meters. So in cubes, we know all the sides are the same, right? So do you want to make this side x? Yes? Which means this side's x. Yes? And this side's x. So then how high is this then? Yeah, from here to here then would be 5 minus x. So then this is 5 minus x, and then I guess this is 5 minus x. Does everybody see how I got those dimensions? Okay, so it's saying that the total surface area is 61 meters squared. So do you remember how to find surface area of composite objects? You find them separately, add them up, and then subtract double the overlap, yeah? Because remember, on this side, we're carrying something. So what would the surface area, I'm just going to call it area. What's the area of the smaller one? Well, one face would be x squared. How many faces total are there? Yeah, so I'm going to start with the whole thing separate. So it's going to be 6x squared. And then what would this be? It's a 5 minus x by 5 minus x, and then there's 6 of them. So it's 6 times 5 minus x, the whole thing squared. And then we're going to subtract double the overlap. What's the area of the overlap? 2x squared. So some of you were already doing that when you, and you can do it that way too. I just want to. It's because this part is, we're counting it twice. We're counting it when we have this big side and when we have the small side. So I'm just going to simplify this. Ooh, no. So that means, good point. We need to take one away there. Yeah, good catch. We don't count the bottom because it's not exposed. It's on the ground, right? What's a monument? So, I know. Okay, so we're going to have 4x squared. Let's FOIL this. What's 5 times 5? 25 times 5. Okay, so now I'm going to FOIL this. 5 times 5 is 25 times 5 is 125. Outer I get minus 5x. Inner I get minus 5x. So that's minus 10x times 5 would be minus 50x. Yeah? Minus 50x. And then x squared times 5 is 5x squared. Okay, so a of x equals 9x squared minus 50x plus 125, and there's nothing I can divide out of that, unfortunately. Oh, so, but I do know 61 has to go in there, right? So there's my next mark. So if I move the 61 over, what do I get? $64? Yes? So is that factored beautifully? I'm hoping so. You're thinking a 3x and an 8? No. A 3x and, well, let's try it. 3x and 3x. Wow. Yeah. 32. That is a lot of work, eh? 16. Well, they both have to be negative, right? I think you found it, by George. No? Does this not work? Well, 3 times 16 is minus 48, and then a minus 12 gives you minus 50, so yeah. So x equals 4 over 3 and 16 over 3. Did I just screw it up? Okay, so we found a mistake. So you think it's 9 and 1, 2 and 32. And minus minus. So that would be 18 and 32. Bingo, bango! We found it. Okay, so that means x equals 32 over 9 and positive 2. We didn't do our restrictions, though, did we? Okay, so yes, x has to be greater than 0 and less than 5. So that means I can... Does everybody understand why it has to be greater than 0? Yes, there would be no dimension there. And it has to be less than 5 because you can't subtract something bigger than 5 or you'll get negative dimension there. How many does 9 go into 32? 3 times. So they're both legit. Both legit. Look at that. Okay. So what does it say there? How come I can't find it? Determine the dimensions of the box. Therefore, okay, so, therefore, there are 2 possible answers. Say what? So, it says determine the dimensions of the block, so it can be a 2 by 2 by 2, and now 3 by 3 by 3.
Yep.
And that, of course, is meters. Well, that's the other block, the big block, right? If I take 2 away, I get a 3 by 3 by 3. Or, oh, the 32 over 9, yuck. 32 over 9 by 32 over 9 by 32 over 9. Oh, but if that's the smaller block, 32 over 9 is how much? 9 goes into that 3. So that'll make this the bigger block. Do you see that? So, well, I'm just saying if this has to be the smaller block, then we are going to reject that because it's going to be this. So it won't be how do you have a monument with a bigger block on top of a smaller block? You know what I mean?
Well, it works, just that's not what it's...
Because it's crazy. Okay, so we're going to reject. Therefore, there's only one possible because you can't have the smaller block. So, okay, last example. Thank goodness. Okay, so I'll repeat. 32 over 9. 9 goes into 32, 3 and 5/9. So if I take 3 and 5/9 away from 5, do you see I'll have a smaller block here? Yeah. Doesn't make sense, does it?
So that restriction would be like 5 minus x has to be greater than.
Guess it has to be greater than 2.5, right? Or less than 2.5. Okay. It says a box is in a shape of a rectangular prism, has side lengths x, x plus 2, and x plus 10. Write a function v of x to express the volume in terms of x. That's easy points, right? And that's probably how I'll have it on the test. A little easier like that. Come up with a v of x. So what would that be? X times x plus 2 times x plus 10. What's the restrictions on the x? So say what it has to be instead of what it can't be. Greater than 0. Very good. Okay. So find all possible values of x given that the volume is 96 square centimeters or cubic centimeters. So 96, here's my second mark, equals. Okay, let's FOIL this. X times x, x squared times x, x cubed. Outer I get 10x, inner I get 2x, so that's 12x. Times x is 12x squared. And then last is 20x times x. Yeah, 20x. Okay, 20 times x is 20x. Okay, so I'm going to move the 96 over. Okay, woo. Dimensions. So what should we go with? Uno? By first glance, I don't think Uno would work. So let's try 2. Tuno? Try. X equals 2. So that would be 8. No, it can't be negative, remember?
Try.
No, it's just because I don't have a variable I can use to say p of 2 or whatever. So I'm just kind of keeping track of it this way. So this is 8 plus 2 squared is 4, so that's 48, plus 40 minus 96. Hey, that equals 0. Good job guessing. So let's divide. 2, 1, 12, 20, minus 96. Bring her down, multiply. Bring her down, multiply. Bring her down, multiply. Okay. That represents x squared plus 14x plus 48. Who's the mighty factor here? What do you think? Yeah, 6 and 8. Okay, so therefore, x equals 2, negative 6, negative 8. Do you see how I listed all the solutions? Now I'm going to reject. So, what am I answering here? The dimensions. So the dimensions must be yeah, 2 and what is this? Meters, centimeters, centimeters. 2 centimeters by 4 centimeters by 12 centimeters. What? Oh yeah, there's a little m there.